Yes.
Okay, so today we are solving rational equations now. So we have equations going on here. I'll shut this light off.
Oh, yeah.
All right, so I'm gonna do a little bit of notes in my notebook and we'll do some practice problems from the sheet that I gave you. And we'll move right along. Okay, so this is 6-5. Solving rational equations. So remember what the word rational means. It really just kind of means a fraction. So we are just solving equations that have fractions in them. Okay, so don't get too hung up with this whole rational business, bless you. That's all it is, okay? So let's actually start with a very reasonable one that you could probably just do in your head. Let's say I gave you something like 3/7 plus x over 7 equals 5/7. What does x have to be? 2, of course, right? Isn't 3/7 plus 2/7 gets me 5/7? Now, take a look at this. See how all of their denominators are the same all the way across? Everybody's denominator is a 7. Would I have gotten the same exact answer if I actually kind of just ignored the denominators? If I just looked at the equation formed by the numerators, don't I still get 2? It's the same answer. So that's kind of going to be our driving force here. If I have an equation, no matter how funky it looks, if all of the denominators match, then I can just solve the equation that the numerators make. It's just that easy. The challenge is sometimes I gotta make those denominators match if they don't already. But those are my steps. That's it. Make all the denominators the same and then solve the equation formed by the top. So let me give you some how-tos and we'll do out some examples. So step 1, we are going to get all denominators to match. I'm going to add that you should factor first to help.
I know it is.
So if you have a denominator that can be factored, you might want to factor it just to help you figure out, okay, let me figure out who's missing what here. All right, and then step 2, you're just going to solve the equation formed by the numerators. That's almost it. The only thing that does kind of come into play a little bit is, let's say I got an answer of, let me find an example here. Let's pretend that I was doing this problem right here. I did all the work out and my final answer was 7. That's a problem. Why would that be a problem? Why couldn't on number 12 here, why would having my final answer be 7 be an issue?
It would create a 0 in the denominator.
Exactly. So it can happen occasionally that the equation formed by the numerators gives you an answer, but that answer won't work in the denominator. And then if that happens, that's called an extraneous solution. We've mentioned those before. That's an answer that you got correctly. You didn't do anything wrong, but it doesn't work when you plug it back in. So you just want to be mindful. So my last step is, I'm just going to say, check for extraneous solutions. It doesn't happen very often, but it does happen on occasion. and you're done. So 3 steps. So we're gonna start off relatively easy. I don't know, let's just do number 1. So from your worksheet, it looks like this: 6r plus 36 over r squared equals 1 over r plus 1 over r squared. Oops. There we go. So I'm looking at this and I'm like, oh gosh, I want all of my denominators to be the same. So what will I have to do to make that happen? Okay, let's,
Square,
what?
and you square, add another R.
Yes, this one just needs to be multiplied by r over r, and then it will match all of the others. So I'm just gonna sneak in here and I'm gonna multiply just this fraction by r over r, which, remember, I'm allowed to do that because r over r is just 1. Multiply anything by 1 and it doesn't change it. Now, can we agree that all of my denominators match? Everybody is r squared? So step 1 is now done. All the denominators match. So now watch, everybody, watch. You ready? Watch this magic. Once all the denominators match, in my second step, I'm literally going to ignore the denominator completely. And I'm just going to write 6r plus 36 equals 1 times r is just r plus 1. And I just solved that equation. Just like a normal equation. So wouldn't I minus r? 5r plus 36 equals 1, and then just solve from here, right? Easy peasy. I got -7, did you? Trying to clean that up a little bit. So that just made it way worse. That's a 5. Yeah, sorry. Then I just take my answer real quick and say, okay, if I put -7 in the denominator, does it make any of my denominators turn into a 0? No, so it's fine. There's no extraneous answers here. -7 is my final answer and I'm done. That's it. The only way that these get harder is by having harder things to get the denominators to match and having a harder equation to solve. Maybe it's a quadratic I end up with, whatever, but they're totally doable. So let's try another one. How about 4? How about you try 4? Everybody try number 4, please. Everybody's trying this, right?
Yeah.
Mm-hmm.
Oh.
Wait, would you
shoot, I
bring
did
it?
wrong.
Yeah. Bring like make the 2 be a 4 square.
Yes, yep. So our common denominator, I think we can agree, has got to be 4v squared.
Yeah.
So this time you got to multiply any fractions you need to make everybody be 4v squared. We got it?
Wait,
What do I have to multiply this middle fraction by? B. I'm gonna sneak in there with a V. And what do I need to multiply this one by?
2.
2. And always make sure, right? Top and bottom. You can't just multiply a denominator by 2. That's not allowed. Okay, but this is now everybody's denominator matches 4b squared. So the equation formed by my numerator should look like this. 1 plus, that's just 3b. 1 times 2 gets me 2. That's it. And now I just gotta solve that. Oh my gosh. You mean it can be that easy? It can be that easy. I get a third. Did you get a third? You guys got a third? Yeah? Did the third give me a 0 in the denominator? No, so it's fine. There's my answer, 1/3. Okay, let's try something trickier. I'm gonna flip to the back. These are, let's do, oh, that one looks really good.
No, was it that one?
I don't think so, but I'm thinking about 10.
Ugh. Okay.
Oh, you know what? No, I'm gonna take that back. Actually, let's do 14 instead. 14. Bless you. 6 over k squared plus 5k minus 1 over k equals 6k over k plus 5. All right, so get in here, there we are. Okay, what do you think we should do first? Let me just reread what we wrote down for step 1. Get all denominators to match. Factor first to help. I would do that. This, can I factor out a k? And then I have k plus 5. See how it makes it a lot easier to kind of see, how I can tell, oh, like, oh, these two already both have k's. So this one will just need the k plus 5. This one already has the k plus 5, it just needs a k. So if you factor any of the denominators that can be factored, it helps you see what pieces already match. You know what I mean, Jelly Bean? Is that a yes?
Yeah.
All right, now I can see, doesn't this one need a k plus 5? Right, the one in the middle needs k plus 5 and the one on the end needs k. Are you guys with me? Where are you today? Okay, all right. So let me sneak in and I'm gonna put in a k plus 5 over a k plus 5. Should leave myself a lot of room there, but that's okay. And then this last one just needs k over k. Now, before I continue, I always stop and I ask myself, okay, is everybody's denominator really the same? Yeah, they all have k times k plus 5. So those are good. Go ahead and write the equation formed by the numerators. Go ahead and write it. Write that, just the equation formed by those numerators. I want to see what you write down. Write it. So just the numerators, write that equation. Because I want to see if you're going to fall into the trap or not.
Probably.
Well, you know that there's a trap, so look out for it. This is the equation I hope you wrote. 6 minus k minus 5 equals 6k squared. Look right here. Did you have a plus 5 or a minus 5? Good. It's got to be a minus. You are subtracting this whole kit and caboodle right here. 1 times k plus 5, k plus 5, but you have to subtract all of it. So it's going to be a minus k and a minus 5. All right, so now I'm here. What the heck am I supposed to do with this now? Where do you go from there? Yeah, I can put the 6 and the -5 together. How am I gonna solve this, though? This is a word I'm looking for you to say. What type of? Quadratic. So I'm gonna have to set the whole thing equal to 0, right? And hopefully I can factor. So let's move everything. I'll move all of this over here. So I'm gonna add k to both sides. And then 6 and a -5 is really a +1, right? So I can just subtract 1 from both sides. And that gets me 6k squared plus k minus 1. And now, my friends, you should be able to factor this if it's factorable. What happens if you can't factor it? You gotta do quad formula or complete the square if you're feeling crazy. But yeah, you would do quad formula. I think this one is factorable. I think so. So everybody, go ahead and factor it the way that you do it. I'm gonna hide my work off camera so you can't just copy what I write, because you are an expert at factoring by now. I know it. You've been doing it for a long time. Okay, did you get an answer? Anybody want to tell me what their answer is? Final answer for the whole thing. Adam, what'd you get? I agree. So you're gonna factor this thing, should factor however you do it. You should get a 2k plus 1 and a 3k minus 1. Oh, hi! There's a spider out there. Oh, that's funny. Anyway. Did you get those two factors? And then you solve. And then we get a -1/2 and a +1/3. Don't forget about step 3. You got to check, will either of those answers give me a 0 in the denominator in the original? Go back to the original problem. If you plug in -1/2 or a +1/3 into the denominator in the original, does anybody turn into a 0? No, so it's fine. Who would have made it turn into a 0? Oh, hi, what up with those spider? I don't know. So in number 14, if you had gotten an answer of -5, for example, if -5 just so happened to come out as our answer, we would have had a problem, right? Because that would have made a 0 in the denominator. Alternatively, if 0 had come out, right? 0 itself, because that would give me a 0 in the denominator right there. So those two answers would have been, we call them excluded values. So before I even start, sometimes you might want to think about, hey, if my answer comes out to be 0 or -5, I'm going to have to throw it away because I can't have those two values that would give me a problem. All right, anyway, I want to do one more that has, let me see if there's a good one. I want to do one where there's just, I mean, it's only 7 or 11. You got a preference between 7 or 11? I'm gonna go 7. I just wanted to do one where there was, one of your numbers was not a fraction. Okay, so 7 looks like this, n plus 5. You know what I like to do sometimes too when I actually remember? Since I know I have to multiply these things by stuff, leave yourself some space. So when I write 1, I'm just automatically going to write it as 1/1. So I know, I just want everybody to be a fraction, that's all. So this isn't so bad, right? Well, how will I get my common denominator? I gotta multiply the middle one by 3n, that's all. So I'm gonna sneak in 3n on top, 3n on bottom. Now everybody matches. So go ahead and try and solve this one. Just write that equation formed by the numerators. And then you just solve. All right, did you get what I got? Yeah? Oh, sorry. I will say, if you have access to a calculator, you can check your final answer, right? You can take 10/3 and plug it back and make sure that it works, because it is an equation. Unfortunately, it's really cumbersome to do that, especially when my answer comes out as a fraction. Like if my answer came out as 1, okay, that's pretty easy to check. But as 10/3, it would take me longer to check it than to just do the problem, right? So anyway, but that is always an option. You can always check your answer. If you have an equation, you can make sure that your answer is correct by plugging it back in. All right, does anybody have any questions about solving these rational equations? They're not that bad, right? Okay, so what I actually want you to do, I hope you haven't lost your little puzzle packet. Oh. I thought maybe we could take a look at
We should do the next lesson, right? Still 30 minutes.
I think we need to practice with this first. I gotta decide between these two. Yeah. No, sorry.
Yeah,
You mean you've already gotten 2/3 of the way through with the other
No,
worksheet?
we haven't.
Hmm.
wow.
We've literally done like 4.
I think I'm gonna do one of these things. I would like you all to complete page 131, and then if you do the second page, 132, I think it is, yep, I'll give you extra credit for that one.
What are we doing?
So you have to do page 131. This is a did you hear about?
I don't know where my pen is. Oh, wait, I got it.
This one right here, did you hear about? So that's page 131. You have to complete for homework this evening. If you so choose to get some extra practice, page 132, I'll give you extra credit for that one. For all of these, you have to have some work. You cannot just be submitting the answers, or you can't just write like, I love this. Kids will clearly photo math this, right? And then they just write the answer right here. They think that that counts as work. Come on. I've literally been teaching longer than you've been alive, so I'm hip to your tricks here. Some of them anyway. I may not know Instagram, but I know photo math when I see it. Yes.
Can I use the bathroom, Octavia?
Sure. Let me see.
Oh, what the heck?
I don't know how many spares I have.
Oh, never mind. I have mine.
Oh, you sure?
Yeah, Maddie just doesn't.
Maddie, you looked through all your stuff?
No, it's like at my house. I know it's.
Oh. You're welcome. I already gave you another one.
Keep leaving them at home. 'Cause I didn't know we're gonna keep needing them.
Yes, oh my
I'll make sure to
gosh.
hold on to this one.
Well, it's the last pages, so. ugh. I know I'm gonna have someone in D block that needs it. Oh, dear. Anyway. Shall I turn the light on?
No, thank you.
Guys,
You see why?
I said, guys, I'm sure it's bad for your eyesight. Is that a myth or is that real? I don't know.